Welcome to the Cypress College EDLA on Arithmetic and Geometric Sequences. Objective 1. Sequences in general. A sequence is an ordered collection of numbers or objects. The notation that's commonly used is a sub 1 is the first term, a sub 2 is the second term, a sub 3 is the third term, and so on and so forth. A sub n is the nth term or the general term. Example. Describe the sequence and determine the next object. We have a triangle and a square and a pentagon and a hexagon. Let's see. Well, this is a sequence of what are called polygons. The first object has 3 sides. It's a polygon with 3 sides. Then we have one with 4 sides, and then 5 sides, and then 6 sides. So the next object in the sequence should be a polygon with 7 sides. So this is a sequence of polygons, and each polygon has one more side. In this example, we're asked to describe the sequence and determine the next term. We have 1, 4, 9, 16, 25. I find it's often easier to determine the pattern by looking at the later numbers in the sequence rather than the first few. So we look at 9, 16, 25. Well, 16 is 4 squared and 25 is 5 squared. Does that work for the other numbers? Well, 9 is 3 squared and 4 is 2 squared and 1 is 1 squared. So these are all perfect squares. So that's describing the sequence. They're all perfect squares. Now what would the next term be? So we have 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. So the next number would be 6 squared, which is 36. So the next term is 36. There's another thing that we can do for this pattern. We can actually determine a formula for the terms in this sequence. Let's use the notation we described earlier. So a sub 1 is 1 squared, a sub 2 with the subscript 2 is 2 squared, a sub 3 is 3 squared, a sub 4 is 4 squared, a sub 5 is 5 squared. So this number, the subscript, matches the base. So if we have a sub n for the general term in the sequence, that would be the base of this exponential expression. So a sub n would be n squared. This is the formula that represents the nth term in the sequence. So a sub n is equal to n squared. That's a formula that represents the terms in the sequence. Let's say we want to figure out then the 10th term. So we use this formula, and now we want a sub 10, the 10th term in the sequence. So a sub 10 would be 10 squared, and 10 squared is 100. The 10th term of the sequence is 100. This sequence has the numbers 1, 1, 2, 3, 5, 8, 13, 21, 34. What's the pattern here? Well, we have 3 plus 5 is 8. 5 plus 8 is 13. 8 plus 13 is 21. That works, doesn't it? Let's check it out from the beginning. If we take these two numbers here, the first two terms in the sequence, and we add them up, we get the third number, don't we? 1 plus 1 is 2. Let's try and see if that pattern works for all of them. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. Yes, that pattern works. This is called the Fibonacci sequence. It's named after the guy that came up with it. It's a very special sequence. It actually occurs a lot in the study of botany, computer science, genetics, and many other fields. Let's find the 11th term of this sequence. Let's list out the terms. So the first term, a sub 1 is 1. A sub 2 is also 1. A sub 3 is 2. A sub 4 is 3 because it's the fourth term. A sub 5 is 5. A sub 6 is 8. A sub 7 is 13. A sub 8 is 21. A sub 9 is 34. Now how do we get A sub 10? Well, to get A sub 10, I would have to add the previous two terms of the sequence. 21 plus 34 is 55. So A sub 10 is 55. A sub 11, I need to add 34 and 55, and we get 89. The 11th term of the Fibonacci sequence is 89. In this problem, we're given the formula a sub n equals n over the quantity n plus 2, and we're supposed to find the first four terms. What does that mean, find the first four terms? It means to find a sub 1, which means plug in 1 for n, and then find a sub 2, and so on and so forth. So here's our formula, and we first want to find a sub 1. We plug in 1 for n, and we have 1 over the quantity 1 plus 2. Can you cancel the 1's? No. You need to do what's in the denominator first. 1 plus 2 is 3, so we get 1/3. That does not reduce, so a sub 1 is 1/3. Now we want to find the second term. The second term of the sequence, we plug in 2 for n. We have 2 over the quantity 2 plus 2. We do what's in the denominator first because of our order of operations. Order of operations says do what's in the numerator, do what's in the denominator, and then reduce if possible. So we have to add the 2 plus 2, and we get 4. Now, can we reduce 2/4? Yes. 2/4 reduces to 1/2. A sub 2 is 1/2. A sub 3, we substitute in 3 for n. In the denominator, we get 3 plus 2, which is 5, and 3/5 does not reduce. A sub 3 is 3/5. A sub 4, we substitute in 4 for n. In the denominator, we get 4 plus 2, which is 6, and we have 4 over 6. 4 over 6 does reduce by dividing the numerator and denominator by 2, and we get 2/3. A sub 4 is 2/3. Therefore, the first four terms are 1/3, 1/2, 3/5, and 2/3.